Hello, my name is Madison Tapp, and this is my PHYS133 Lab project. So I'm just going to go ahead and start talking a little bit about the project for this week. So it's talking about the relationship between pressure, gas, and volume. And gas is a fluid, so it takes on the shape of whatever it's filling, as we learned in our pre-lab. And a temperature is the kinetic energy that the gas takes, so the kinetic energy of the molecules moving past each other. So faster, more with molecules moving with more speed is going to be hotter, and then if the vibrations are really small, then that's going to be a cooler temperature. And pressure is the amount of force that gas molecules put on the space that they're in, and volume is the actual amount of space where this pressure is occurring. So the ideal gas law is what we're using this week to calculate these measurements, because the change of one of these can result in a different answer. So we're looking at the relationships between the two. So the equation is PV equals nRT. So that's the pressure times the volume equals N is the number of moles of the gas that's present in what we're looking at, and then the R and T. R is the universal gas constant, and T is the temperature. And then from here we look at these to see how they correlate, seeing the spaces that they're occupying and relating them to the temperatures and the places that they are in. And then if atoms don't move at all, that means that they've reached an absolute zero, which it's not possible to get an absolute zero. So we won't be getting that in this experiment. But if the molecules are moving or not moving at all, then that is absolute zero. And so what our actual project is, or our lab is going to be for this week, is looking at that relationship, taking down points and graphing them, seeing how they actually do look. So we have our cup and our syringe, which are really important in this exercise, or in this experiment. And so what I did, I went ahead to kind of show you, so you get the syringe to halfway and you screw it. So this is, I did it at the 5 right here. So it's filled halfway with room temperature air, and I'll plot that down, see the temperature of the air and everything. And then once I get the temperature here, I get hot water and I put it in the styrofoam cup. Not too hot, as a safety precaution. And then I'll put the syringe in the cup, then measure the temperature of that, and where the pressure gauge is in here. And then once I have the measurements for the hot water, I'll put some ice, or I'll get water and put cold water in here with ice and see how that affects it, and take the temperature again, record that down. So, and I'll do it after 30-second increments. So I'll put the syringe in, time it for 30 seconds, then see what my overall result is for the temperature and the pressure and everything. That's whenever I'll do the measurement. So it'll be after 30 seconds. And then I have my graph paper here that I'll record all of my data on, and the chart that was listed with us. And then I'll go through, answer all the post-lab questions. And once again, my name is Madison Tapp. My student ID number is 5725256. And I think that is all for this lab experiment. So thank you very much. Have a great day.